Hang on. Can you see the screen already?
Yes.
Okay. Job, human resource, okay. So let me see where we actually finished last week. Okay, we have talked about this. Okay, I think I did ask you to do one flow chart, process flow chart. I haven't written that nicely, and nobody have actually started to do the process chart. Probably we need to have a description. Okay, I will have that described into the OMG. Okay, I think we already covered until here, and right, and we stop here. Remembered, Jacob? Or
The virtual workplace.
okay, visual workplace. Okay, probably I'll start here. Okay. Now, so we need to actually, now we're talking about the work environment, okay, and also documenting and measuring our work. And one of the things is actually to have information and also procedures that in the workplace. In the workplace, you need to have some access to information quickly and accurately. So you can use what you call manual forms and so on. Okay, so low cost visual devices to share information quickly, or you can have graphs or displays to replace printouts and paperwork. That means you can immediately see the progress of your work in the workplace, having these graphs or displays. And if it is a dynamic environment such as the production is very dynamic. The things change very fast. New information comes in. So for example, a supplier missed to deliver. So what need to be done? So you must provide timely information to the workplace, to the production line, in order for for production to continue doing the work, okay, or to do some countermeasures. And in the workplace system that you have should focus on improvement. That means the workplace must always be, trying to convey better, better form of information, because you want to, make sure that the employees knows what is happening. Visual signals that you use on the workplace or normally in the production line, okay, production line, it can have, it has many forms and it will have many functions. Some of them are for performance purposes, some of them are for housekeeping. Let me just show you, some of the visual. This is, when you talk about operations excellence, organization that actually has a good system, they will have, proper places to ensure housekeeping. This is just an example of our home, but you imagine a factory or a shop, a workshop or mechanic workshop. You see a place in which it is not arranged. The tools are everywhere. So when the tools are everywhere, you cannot ensure jobs are being done properly. So you cannot follow the standards. Okay. For example, this is 3-minute service clock reminding employees of the goal. The goal is to provide they deliver the service within 3 minutes, and records, for example, showing the actual. So these are visual workplaces. You can have, and Japanese love this a lot. Okay, you can see, you observe in what you call factories or even in train stations. You can see all these visualization, visual control, visual country. What else? Okay, so have you ever seen this kind of lights? I think it's in many manufacturing companies, or even in places, like train station also they have this. So this is actually visual signals to notify or to support personnel about what is happening on the situation, gemba, and at the actual place. Whether the machine is stopped, so there will be a red light rotating and blinking, red light blinking. So it shows that the machine is having trouble. So you stop the machine. So that when the manager goes to the factory, he goes to the production line, he can actually know which station is stopping and he can take measures, okay? Or there is a red, so these lights are, it must be, it's good to have all green. Green, you can see all green, then you know everything is running perfectly. But when there is red, then you mean you need to take some action. So this is visual control, visual control on the workplace. Or even visual Kanbans. Do you know Kanbans? Have you heard of Kanban before? In production line? In Toyota production line, do you know, you have heard of Kanban? Kanban is just signal, okay? If, for example, the the amount of material drop below this level, so you need to be replenished, need to be added to the storage, okay, or to the production line. So these are visual control. Visual Kanbans will reduce inventory and also ensure JIT, just in time system. Okay. So it's not only about just getting people to do things in production line, but you must make sure that they actually know what is happening. What else? This is company data processing specifications. This is very common in manufacturing companies. They have operating procedures. So when you go to the shop floor, this is 5S also. You know 5S? Seri, Seton, Seso, Seketsu, Sisuke, 5S. 5S, okay? Seri, Seton, Seso, Seketsu. This is Kanban. Quantities in B indicate ongoing daily requirements. This is I've seen in a factory, in not only factories but also when you go to service your cars. For example, when you send to Toyota service centers, service your cars. That means you send for oil change or repair. Every 10,000 kilometers, you need to change your oil, for example, okay, your engine oil. When you go to the Toyota service centers, so they have a board which they will arrange uh, the incoming work to be done sequence, okay, so that the foreman will go into this board and pick up the information or the service required, then go to the car and pick up the car and go to the service booth, service area. So it is once it's completed, okay, they separate. This is not done, okay, this is completed, and so on. Okay, so they go to this, once it's completed, they send there, and then the person who take care of the billing can go to here and check the completed vehicles and call the customer and ask for payment. So it's a visual system rather than having unclear. Okay, so all this can be made very systematic. If only companies think, Jacob. If only companies think about it. Have you ever seen this kind of visual? Can you think of something of this nature that you can do in in organizations? I'm just giving you an example. Just now, Toyota customer comes to the service center. Of course, the person who gets the order, then you can wait. You wait in your waiting room. So the car is being processed. Okay, they give you time. How long is it take? Toyota very good because you come at 8 o'clock in the morning. If they say 10:30 completed, the service can be done. It is according to their promised time. Okay. How they do it? Because they have work standards, time study. Okay. Right. So that brings us to labor standards. Labor standards. So labor standards, if you, I'll go to the second point first. Labor standards are the amount of time required to perform a job or part of a job. Okay. So you can find the time required, for example, to change the battery. Okay, change the battery. You can take a stopwatch and measure and record down. So for every workers, you can actually know. How long does it take to clean a room in a hotel? How do you determine the time taken to clean a room in a hotel after the person has checked out, right? So how long does it take to do the housekeeping, the cleaning, change the the linen, change the towels, put in the new shampoos, and so on. How do you do
It
that?
depends on the room size, I think also.
Okay, so
Also
you
cleaning the
have
room, it
a
will take some
few
time.
few size A, size B, size C. So how to determine size A? So I'm going to teach you how to do the, how to take the, not detailed, but roughly how to actually. So it is important because accurate labor standards is needed to determine labor requirements. If I have 100 rooms, okay, and occupancy is 50%, 50 rooms, so I need to clean 50 rooms on the average every day. If I know the time, I can know how many people, I can know how many employees is needed, and I know the cost. Okay, so that's why you need to know labor standards for effective manpower planning. Meaning that if you do not have labor standards, how long does it take to do a job, especially manual work? Then you cannot cannot have effective manpower planning. You cannot measure productivity. You cannot measure productivity. Productivity is output over input. Okay. Right. So it's actually started in the early 20th century, and this is important to all organizations. Okay, both manufacturing and service organizations, and it is important to both manufacturing and service. That's why I give the example. I ask you to think about a hotel. Okay, so that's a service. I can always give you example on manufacturing, how to assemble tire on the car. You know the car, right? How to fix the tire on the production line. And of course, it is, you want to know time standard because it will help you determine staffing requirements. And also to, for giving incentive system. Last week, I think, we mentioned about the garment industry, textile. They make shirts, clothes. So it is dependent. If you know how long to take to make one shirt or sewing. You know sewing. You know sewing means
Yes, yes.
to. Yeah. So one day 500, but if you make more than 500, every single piece extra you give incentive, piece rate, for example. So that is labor incentive. How do you know how much to make in a day? So you need labor standards. You need so meaningful standards will will help determine the labor content of items
Professor,
produced. Yes.
is it labor intensive
Incentive.
or
Incentive means
incentives? Okay, incentive means like extra payment.
extra payment.
All right.
Extra
Yes.
payment, labor incentive.
Incentive. Yeah.
So that's why it is the basis of wage incentive plans. If you have
Yes.
labor standards, it is the basis for wage incentive plans. And you know the job content, you know the staffing requirements, costs, you can estimate the cost, you can estimate the crew size. Crew size means how many person to work in the, the production line, and you know the expected production as well efficiency. So it is important to know the standard time. So if you do not have the standard time, you will definitely not, able to determine how much to produce or even promise to customers how much you can deliver to customer. Okay, labor standards can be set in 4 ways, 4 types, 4 methods, 4 methods. Okay. One is historical experience. And then time studies, predetermined work standards, and work sampling. So I'm going to focus more on time studies, okay, and a little bit on predetermined time standard or PTS, and little bit on work sampling, mostly on time studies. I'm going to focus on time studies. But these are 4 methods. Historical experience means how long does it take for you to prepare your dinner, Nian? How long does it take for you to prepare your dinner, which have rice and one meal, okay, one chicken or one fish? How long does it take?
From 5 minutes to 10 minutes.
Wow, hayai ne?
Yes.
5 minutes to 10 minutes.
Okay, Yaakob, how long does it take for you to prepare dinner?
Dinner.
Dinner,
1.5 hours.
1.5 hours. Okay, Wenjia? Dinner of
maybe 30 minutes.
30 minutes. Okay, and also I will ask, where is Rio? Rio, how long does it take for you to prepare your dinner? Historical experience.
Also 30 minutes.
30 minutes. Okay. How long does it take for me to? Okay, another, maybe because it's a lot of variation. How long does it take for you to do your case study? Last semester, I give you case study. Donogurai jika enggak Kakarimas. How long did it take for you to do in average, okay? In average. Just remember back, historical experience, how long did it take to you to complete the case study that I gave you? Yaakob? 1 day, 1 hour, 2 hours? It's okay. It's not right, wrong answer. It's historical experience. Nian?
Yeah, about 4 hours, I think.
Okay, last semester I gave you case study, the shop. How long does it take for you to do average 1 case study? Or remember 1 case study I took 1 day, the other one
It's
I
like,
took,
1 day, I think.
Nian,
4 days.
4 days.
Every day.
Every day. Vijay, how many days? Historical experience, how long? Dono gurai jikan kakarimasta.
Every day.
1 day.
1 day. Rio?
Yes.
Wasurita?
One night.
1 night. Okay, 1 night. Right. So that is experience, historical experience, right? And of course, based on, but when you go to real job, like for example, prepare a report for your manager. prepare your, for example, prepare for this class. Set up Zoom, okay. Dono gurai jikan kakarimas. Set up kyo no class. How long does it take for you to set up from open computer, switch on computer until you get connected to Zoom? Okay, Jacob. How long? 5 minutes, 10 minutes. So that is based on your experience. Average, on average.
What was the question,
The
Professor?
question was, from every time you want to attend class, like this class, switch on computer. Okay, assume you didn't switch on the computer. Assume
Okay.
morning, now you are going to have the class, switch on computer, Google, check, Zoom. 5 minutes?
Yeah,
1 minute?
at best 5 minutes.
5 minutes. Nian?
Oh, it takes 2 or 3 minutes, I think.
Okay.
2 to 3.
So next time, if you want to find the standard time, then we can do proper time study. Okay? Rather than based on historical experience to decide a job, content, and also time, it is very variation. There's a lot of variation. So when you do a work, we can have this. So historical experience is how the task was performed last time. Easy. It's easy because you don't have to do anything, just based on your feeling and opinion. Data is not objective and maybe not accurate. Not recommended for continuous work, not recommended. So for production line, for service jobs, we must have time studies. Time studies involve timing a sample of a worker's performance and using it to set a standard, meaning we are going to actually take the time, use a stopwatch or use, what they call, well, stopwatch basically, okay? But of course, to do time studies, some professional detailed work, it require training and experienced observers, okay, for real production line. And you cannot set before the work is performed. That means you have to have the work, then only then take the time, okay? That's time studies. So basically, so it's actually, okay, we'll start with time studies first. Now, how to do time study? How to do time studies? First, we need to define the task to be studied. That means we want to determine what is the content from beginning until end. For example, that's why I gave the example just now. The task is when we switch on the computer until you get it connected. Okay, that is the task. So same like production line. If you want to install the tire onto the car, so you need to define from where? From the worker, pick up the tire, bring it to the car, and install, tighten. So finish. That's the cycle, right? Because it goes into the second step, which is divide the task into elements. So from the big, for example, the first task, the first element is switch on the computer. Switch on the computer. 10 seconds, 5 seconds, you take the time. And then, search for these apps. Okay, for example, how to search, how many seconds? Millisecond, you can measure milliseconds. Open, right? Divide, you need to divide. But big task is very good. For example, you can actually, break down into precise elements. Then you decide how many times to measure the task. So we need to have this frequency, how many times to measure, because we have to determine the accuracy. If you take the measurements too few, then you are going to actually result into inaccurate determination of the time standard. And then you record element times and rating of performance. So this is the difficult part. The difficult part a little bit is the rating of performance. Rating of performance means you are going to decide what pace, how fast is the worker doing the job, how fast. Okay, of course it depends on experience and so on. You don't want to fix a performance. For example, very skillful worker doing the job and you put in a very fast rate where new worker come in will not be able to follow that. So you must have the normal time, okay, normal time that everyone can follow. Then you compute the average observed time. So once you have your time taken for all the elements, I'll show you an example after this. Okay, I'll show you an example after this. Then you can compute average observed time. Average observed time is the sum of the time recorded to perform each element divided by the number of observations. So that's the average observed time. Then you determine the performance rating and normal time, which is average observed time multiplied by the performance rating factor. Okay, so that's why I say performance rating factor is depending on the how fast the worker is actually, or the person doing the job is performing the work. Okay. And step number seven is you add up the normal time for each element. So you must add up all the element, the normal times. Then finally, you calculate the standard time. So you need to calculate the standard time, use this formula, which is total normal time, which is obtained from step number 6, divided by 1 minus allowance factor. Okay, this is also a factor given to accommodate for things which are unavoidable. Okay, you need to give some rest time, you need to give some fatigue allowance. Okay, in order to make sure that you do not give too short time. Okay, you give too short time, whereas the worker cannot actually complete the work. Okay. Now, so this is actually allowances. Okay, allowances that is given for work depending on the work. Actually, depending on the work, there is a personal time allowance, delay allowance, fatigue allowance. And all this actually, there are standards for this, and also there are company policies. So companies will decide what is the amount of allowance given, right? So for example, this is allowance factors for various classes of work, constant allowances for personal allowances, basic. So this is in terms of percentage. How many percent? 5%, 2%. For example, if the work is always in abnormal position, that means it is a very difficult position, bending, lying, stretching, you give some percentage of allowance. What it does is actually you will actually add to the normal time. Basically, 1 minus the allowance factor. We'll see an example after this. Okay, use of force. These are from standards, from tables. Standard tables given for us to do the calculation. For example, muscular energy in lifting, you need energy, 20 pounds of weight. So you're given 3% more allowance. If it is higher weight, until 70% of, the allowance given. Okay, remember it's going to be added here. Okay, so it will increase your standard time if you increase the allowance factor. We'll see the example of this. Right. Okay, let me just. Let me just use the book because the explanation is it straight goes into calculation. Okay, I want to explain based on the details. Okay, let me just hang on. I thought I've already opened the screen, but it's not showing on my screen, so I cannot share that with all of you. So I need to go back to my desktop and open up the book. Okay. So let me just share this this book. Can you see the, cannot see yet, yeah? You cannot see anything yet?
Cannot see.
Hang on, hang on. Okay. I cannot share. Can you see the slide? Can you see the book?
Yes.
Huh?
Yes.
Ah, okay, okay. So you can see the book, eh? Right. Let me just, and if you can open the book also, it's good also because I'm going to use this same example that is in the slides, but the slides doesn't have any explanation. So that's why I need to open this book. So can you see the screen now? Everyone can see? Okay. Can you see the screen? Right. So example 1, determining the normal and standard time. So if you read slowly, if you read together, the time study of a work operation at Red Lobster restaurant, okay, it's a restaurant, gave average observed time of 4 minutes. Okay, some work being done in the restaurant, okay, whatever it is. So some work. And the analyst, the person who do the time study, rated the observed worker at 85%. You understand? The observer, I mean, if I do the study, I give observation that he is working at 85% out of 100%. Okay, that means he is quite slow. Understand? 85%. So this means the worker performed at 80% of normal when study was made. Now, the firm or the company uses a 13% allowance factor. And Red Lobster wants to compute the normal time and the standard time for this operation. So what we need to do is just apply these equations that I shown you just now. Okay, which is, so the solution is this. Average observed time is 4 minutes. So the normal time is average observed time times performance rating factor, which is 4 times 0.85. So it is actually 3.4 minutes. Now, so observe means the one that you take, understand, that you actually measure, that is observe, you measure. So the standard time, using the formula, normal time divided by 1 minus allowance factor. So allowance factor is here, 13%. So 3.4, which is here, divided by 1 minus 0.13. So if you open your calculator and you do the punch, the calculator, 3.4 divided by 0.87, see, you get 3.9 minutes. That's why I said that you are giving allowance. The higher the allowance, this will increase, right? Compare 3.4 with 3.9. If I say work at 3.4 minutes with no allowance, that means the worker will not be able to do the work. So now I've decided, I've done the calculation and the standard time is now 3.9 minutes. So you're given enough time to actually do the work. So because the average work, okay, that's another reason. Because the observed worker was rated at 85%, that means slower than average. The normal time is less than the worker's 4-minute average time. Okay, so that is, you know, he should be working a little bit faster, you know. Right. So if the observed worker is rated at 115%, okay, what are the new normal and standard times? Okay, how do you do that? Any ideas? Any ideas? Can you tell me? Can you, someone help me to, if the observed worker is rated at 115%, what are the new normal and standard time? The answers are here, but how do you do it? Anyone? I can share the screen with all of you. Jacob, you're not opening you're muting your mic.
Oh.
Okay, so what is the normal time for this? Okay, just use the short form. NT
Just
is equals to?
Average observed time is 80%. Which one?
This one. If the observed worker is rated at 115%, initially it was 85%. So what is if it is rated as 115%?
Okay, I can calculate it, no problem.
No, I'm just asking you how to do it. How to do it? Tell me, just tell me. Nian, NT is equals to?
4.6 minutes.
Times. Don't get that. Okay, 4.0 times?
Plus
Multiply?
115%.
1.15.
Yeah.
Correct.
Six,
So not
4.6%, 4.6 minutes.
Right, 4.6. How do you get that? So you get the answer. This answer, standard time is equals to this answer divided by 1 minus 0.13. So you'll get 4.6.
You can give
Sorry.
here 1. 1.5.
0.287.
Also, you can directly give like 115%.
Okay, so that is also another way. Up to you how you are going to do it. Okay.
Mm.
So I'm going to give you some questions after this, so bear with me. So this is a much more detailed. This is much more detailed. That is very straightforward. But how did they get the average observed time? So now, because just now when I said determine the task, then break down the task into elements. So this is what we call by breaking it into elements. So this Management Science Associate promotes management development seminars by mailing thousands of individually composed and typed letters to various firms. So they write letters and they send. A time study has been conducted on the task of preparing letters. So the task is preparing letters for mailing. So on the basis of the following observations, this is already observed and time taken, right? So he wants to develop a standard time for this task. So I want to determine the standard time. So the firm's personal delay and fatigue allowance is 15%. So the company have decided that allowance is 15%. And if you see here, there is a performance rating for each element. Understand? So what you need to do is actually find the observed time for each element. So we need to find the average observed time for each element. Element A, element B, element C. Okay. But before that, okay, this is also very important to do or to recognize. Delete unusual or non-recurring observations. If you observe here, compose and type letter, first round, so this is actually the first cycle, first cycle 822, second round 1031, 925, 2112, 1131. Okay. So it says delete unusual. So what happened is that you see this asterisk here. So this is actually deleted and not used as data. Sometimes we need to actually remove data because those data is actually not, it's going to disturb your average value. Because 8, 10, 9, 11 is okay, but 21, it is something is wrong here. Maybe the, person who actually did it stuck with something. Same here, 5. So 21 and 5 is actually not taken into account. Okay. So you can continue with this. The others is the same: compute average time, normal time, and then standard time. Only the number one: delete unusual or non-recurring observations. So what happened is this. So number one is delete observations as those marked in the asterisk. So that's why it's deleted. Then only you can go to the second step is actually compute the average time for each job element. So average A is 8 plus 10 plus 9 plus 4 divided by 4 only because 21 was removed. Okay, so you 9.5 minutes. B, 2.2 minutes. C, 1.5 minutes. Don't make mistake of, because you have to take how many data was taken because that's average. Then calculate the normal time for A. So you observe the average observed time is 9.5 multiplied by the performer rating. It's different, the performer rating for each element. So you have to use this table to actually determine that. Okay. Then normal time are calculated for each element because the performer rating vary for each element. And you add the normal times, calculate the standard time, so you get this. Okay. So what you different here is that when observed time are not consistent, they need to be reviewed. Abnormally short times may be result of an observational error and usually discarded. removed. Abnormally long times need to be analyzed to determine if they are also error. Okay, so they may include, but however, they may include a seldom occurring but legitimate activity, which you know you need to be considered. Okay, this is something that probably you can continue to do that. Okay, now another important thing in time study is sampling process. So how do you know that the sampling error is not too high? Okay, or you don't you want to know whether your sample size adequate or not? Adequate sample size. Have you taken enough samples? So we want to actually, when you want to determine whether the sample size that you take is enough or not. For example, if we want only 5% error or 1% error, so it depends. So this comes from our level of confidence. Okay. For example, if Z value is 95% confident, this comes from our normal distribution. Okay, normal distribution, 95% confidence. Okay, 95% confidence. You must have seen normal distribution before, right? Obviously, if you don't see normal distribution before, then probably you need to revise back your statistics. Okay. So how accurate we want to be? For example, 5% of observed time are close enough. Okay, the 95% level of confidence or 99%. Okay, the higher the accuracy, of course, the more the samples that you have to actually take. So the formula for appropriate sample size is given by this. Required sample size N is ZS divided by H X bar multiply, to the power of 2 squared, okay, to the power of 2. H is accuracy level. That's expressed as decimal, 5% is 0.05. Z is the number of standard deviation required for desired level of confidence. For example, 95% confidence is 1.65. That's why I said you need to understand the normal distribution, Z transformation. It's given here already. If your desired confidence is 90%, Z is 1.65. So this is Z value or the standard deviation required for percent confidence. 95 is 1.96, 95.45 is 2.0, so 99% 2.56. And you use this formula. S is standard deviation of initial sample. So you need to know this, the initial sample standard deviation and also mean. Then only you can determine the desired or the required sample size. So N is equals to Z divided by S, ZS divided by HX bar to the power of 2. So you cannot understand if you don't see an example. So that's why the next example 3 is computing sample size. Of course, if you have data, you know how to calculate. You know the standard deviation, okay, and also the average. Average is very simple. Average is just now we calculate already just now. Sum of X divided by N. Okay, sum of Xi divided by N. So this company has asked you to check a labor standard prepared by analyst. So you want to know whether he's accurate or not. So you want to determine the correct sample size. Your accuracy is to be within plus minus 5%, and your confidence interval or level is 95%. The standard deviation of the sample is 1, so this is given, okay? So it's already from the data, and the mean is 3. So if the standard deviation is 1, the mean is 3. If you plug in the formula, H equals to 0.05, X bar is 3, S equals to 1.0, and you can find Z from the previous table just now, 1.96, because 95% confidence. then N is 171 samples. So you recommend a sample size of 171 before you can conclude that the standard time is accurate. If not, the standard time is not accurate, has some doubt. Okay, so that is determined. You need to know this thing. That means when you do the sample time standard, you need to have, you need to confirm the sample size. Okay, right. Any questions?